All right, so if you're watching this video, then you are looking for retaking our Unit 5B summative. Okay, so I'm just going to go over what you would have learned in that section. Okay, so first of all, we learned that the sides of, we have to be able to identify equations of a line that could be parts of a quadrilateral. So let's break this out. So first of all, get my pen going. If I put this parallelogram on a graph, I'm saying, okay, what could the equation of these lines be? These lines would be parallel. So when I'm looking at y equals mx plus b, all right, this indicates my slope. Parallel lines have the same slope. So this could be any equations that have a different y-intercept and the same slope. So we're looking for this number to be the same. Okay, and where do you see parallel lines in these shapes? It could be those two lines. It could be these two. It could be these. Opposite sides of any of these parallelograms would have slopes that are equal. So all of these places, two equations with equal slope. 4x plus 7, y equals 4x minus 8. These numbers don't matter. What matters is these have to be equal to be a parallel slope of the line. The other two places you'll find it is opposite sides, or the bases of a trapezoid. Here and here. Okay, so when you took your test, you were asked to pick two equations that were whatever, and it would say opposite sides of a parallelogram, opposite sides of a rhombus, opposite sides of a rectangle, opposite sides of a square, bases of a trapezoid, and all of those answers should have been to find equations that had the same slope, equal slopes. Okay, then the other question is, where do we have perpendicular lines? So the sides of a square, if you put this on a graph, this line and this line would have perpendicular slopes. This line and this line would have perpendicular slopes. These diagonals would have perpendicular slopes. We're putting it on a graph. Perpendicular slopes. These are the diagonals of a rhombus, diagonals of a kite, diagonals of a kite, diagonals of a square, and the consecutive sides we call consecutive sides is when we have one side touching another, one right after the other. Consecutive sides of both square and rectangle. All of these slopes should be opposite reciprocals. So let's talk about whether or not it's a parallel slope or perpendicular. Again, parallel looks like this. They are equal. Perpendicular, we abbreviate it like this, makes a 90-degree angle. Any numbers that are opposite reciprocals, so you're going to look for 5. If 5 was one slope, you're going to look at another slope like this. So you could pick this equation. You could pick this equation. Opposite reciprocal. You're going to flip it. So turn this into a fraction. Flip it upside down and flip the sign. Positive to negative. Let's look at a few more. Here's some these two. Well, 1 is just 1 over 1. Flip 1 over 1. And you still get 1 over 1. One's negative, one's positive. So one has to be positive, one has to be negative, and they have to be the reciprocals of each other. The only other peculiar one is when you would see an undefined slope and a zero slope. And that, as far as choosing equations, a zero slope is just not going to have an x value. So it's going to be on a graph something that's straight up and down and something that is a zero slope. Okay. So that's what you're looking for in the first part of the test. Identifying what line these two lines on a graph, what could they be? They could be what part of these shapes? Okay, so one more time. This is what you're looking for perpendicular. This is what you're looking for parallel. Okay. This is actually your old test I pulled up. We'll use this one as an example. Now, if you are having to retake this, I'm going to assume that it did not go well. I'm going to show you the distance formula. And there are ways the distance formula can be easier. It just depends on how well you are at finding opposite reciprocals. So first step would be to plot this. So I'm going to go over 2, 2, 3, 4, 5. And I'm going to label that. I'm going to go over 1, 2, 3, up 1, 2, 3. I'm going to label that. -2, down 3. I'm going to label that. And -3, -1. I will label that. Okay, so I've got this, what looks to be, it could be a very long skinny rectangle. It could be a parallelogram. It's kind of hard to tell at this point. All right, so using distance formula, 2 ways you can do it. You can actually use the distance formula, which means I'm going to find, okay, well, first of all, I've got to find the consecutive sides. So I'm going to, let's go ahead and label what we're finding the side of. So in this case, I might find ZP. And then I would need to find PR. And then consecutive sides. So first step is find the distance of consecutive sides. That's step 1. All right, so you can use coordinates, and then I'm going to say from Z to P, from Z to P would be, I can do x minus x, which would be -3 minus 2 squared plus, and y minus y squared, -5 squared plus -6 squared. -5 squared is 25, -6 squared is 36, and this equals the square root of 61. Okay, now that's using the distance formula. I'm going to show you, you can also do a little bit, I think could be a little bit easier. All right, so now I need to find the distance of PR. Well, distance formula, if you remember, is simply a version of Pythagorean theorem. So let's take a look at this real quick. The distance from P to R, well, if I go down 2 and over 1, this makes a little right triangle. Let's make this bigger. Makes a little right triangle. So remember, the distance formula is just a variation of Pythagorean theorem. This distance squared, the square root of this distance squared plus this distance squared equals the hypotenuse squared. So I can get this distance by just counting as well. So I have to go from here to here, I've got to go down 2. So that's a change. That's a distance of 2, square it. Okay, to go so I went down 2. Now I'm going to gotta get over 1, and that's a distance of 1. 1 squared. Oops. Okay, work this out. 4 squared is 4. 1 squared is 1, so the square root of 5 is the distance from P to R. So then I can compare what the distance of Z to P is square root of 61. P to R is square root of 5, clearly. So the question is, are those equal or not? So they are not equal. Okay, if they had been equal, then I would say, well, consecutive sides were equal. That would leave me 2 choices, rhombus and square. These are your equal choices. But these were not equal, so that means I've either got a rectangle or parallelogram. Okay. Then I need to do one more check. I need to check the distance of the diagonals now. So I'm going to write down, I'm doing from Z to R. Doing from Z to R. Okay, well, let's just count it out. From Z to R, that means I got to get from here to there. So just kind of sketch out that route. I'm going to go up 1, 2, 3, 4. That distance is 4 squared. I got to go over 1, 2, 3, 4, 5, 6. That distance is 6 squared. So now I have a square root of 16 plus 36. I have a square root of 30, 40, 52. That's the distance from Z to R. See the little triangle there? We're just doing Pythagorean theorem, which is also the distance formula. Then the next choice would be to go, the check would be PY. Okay. P to Y. So I'm going to go up. Let me do another color. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. 8 squared. Then I got to go over 1, 2, 3, 4. 4 squared. And that equals 64 plus 16. And 60, 70, 80. That's the square root of 80. Okay, so now I'm going to compare these two. Now I eliminated these two on my first check. Now I'm going to ask, is the distance of the diagonals equal or not? If it is equal, it must be a rectangle. Things that are not slanted have equal diagonals. But if it's slanted, one diagonal is longer than the other. So in this case, I got square root 52 and I got square root 80. So this is got to be a parallelogram. Okay. Let's do one more. I'm going to show you the problem. This is actually number 4 off your test, but I ended up not grading it. Try this one. We're going to be using these numbers. Okay. Pause the video, see what shape you can come up with, and then come back and check it. All right, first step is to plot all of the points. Okay, so this is the shape I'm looking at. Looks like it could be a square, but we'll find out. All right, so first check is consecutive sides. I'm going to write down, I'm going to get the distance of LO, and then I'm going to need the distance of LM. And then I'm going to compare those two. So the number one check is consecutive sides, two sides that are touching each other. Okay. You can plug coordinates in, or you can just start counting on your graph. Make sure your graph is accurate though, because this won't work if you don't have an accurate graph. So to get from L to O, I'd have to go 1, 2, 3, 4, 5. 5 squared plus over 1 squared. That equals square root of 25 plus 1, square root of 26. Okay. To go from L to M, I had to go up 1 squared, and I have to go over 1, 2, 3, 4, 5 squared. Okay, and we can see that those two distances were equal. So the two shapes that have equal distances, square and rhombus, have equal distances. Rectangle, parallelogram do not. So we're looking at one of these two choices. Rhombus or square. Now I need to see if this thing is slanted or not, or if it has the same diagonals. All right, so number 2, check diagonals. All right, so that means I need to check MO. So I'm going to go 1, 2, 3, 4, 5, 6. 6 squared. I went 1, 2, 3, 4. 4 squared. I got 36 plus 16. 30, 40, 52. All right, now I'm going to go LN. All right, how do I get from L to N? I'm going to have to go 1, 2, 3, 4. One, 2, 3, 4, and then I have to go 1, 2, 3, 4, 5, 6. Okay, so this equals 16 plus 36. I can see right now these numbers are going to be the same. All right, so now to go back, we were down to rhombus and square. The shape that would have equal diagonals, because it's not slanted, would be a square. Okay, and that's all you have to do, is be able to do those two checks, consecutive sides, plug in numbers for distance formula, or you can also just count them on a graph. How long, but you got to take that that up and over route, just like if you were counting slope. Plug those in, and then it's just a different elimination. So first check is, are the consecutive sides equal? Yes, so that's rhombus and square. If not, you're looking at something that's longer and maybe shorter. So rectangle, parallelogram. And then you're going to check diagonals. And equal diagonals would be either the square or the rectangle. If they're not equal on the diagonals, you're looking at rhombus or parallelogram. And that is all there is to know there. Let me know if you have questions. Good luck on second attempt. I'm not sure yet if it's going to be on paper or on computer. But either way, that's what you would need to do. All right, talk to you later. Bye.